Hi everyone, welcome to my channel Mlearner. So in this video, I'll be sharing about the roadmap of this ML data science course. So and the main reason I'm creating this course, as I already explained in one of my previous video, is that I'm trying to solve uh, two problems which I have observed in this in the on the YouTube on the YouTube. Like whoever is teaching the machine learning or data science course, they're approaching this data science as a breadth first way rather than depth. So I want to tackle that by teaching you what are the concept in most clear and most depthful way, unless it is too technical or unless it is too mathematical. What are the topics which are essential? I'll teach them in most clear and most in a foundational way. Okay, that is the first thing. And the second thing is that they're not following the clearer structured way of teaching. That means they're teaching the topics in a random way and then they're creating a playlist which becomes harder for anyone to follow through. Like whoever is starting to learn, it becomes hard for them to follow because they're not creating the video in structured format, especially because this data science is very vast field. In order to become mastery in order to master this field, you have to you have to have a structure and a formalized way to learn this, right? So that is the second thing I'm trying to tackle by creating this video. Anyway, so let's see what are the different modules. First of all, this course is divided into 10 modules, ranging from understanding the basics, which is understanding about data, to the Gen AI topics, which is very trendy and advanced topics, right? So we will go step by step. And also this 10th module, which is real world use case. So whatever we'll be learning over here, we'll try to apply them in by solving any real world use case. I'll try to take any two real world projects and also try to deploy them. Okay, we'll be discussing them while I discuss about this module. Okay, so let's start with the first module. Uh, One thing I want to add over here is that you must need Python programming. So there is programming, right? So don't get scared when I use this programming word. The programming which you require for data science AI is basic compared to what devs or developers are using. Okay, so we'll be not I'll be not covering Python over here because already there are good tutorials for Python for data science. I would recommend you watch those tutorials. I'll give a link in the description of my of one of the good tutorial for beginner by Dave. So he has really created a good tutorial for Python for data science or AI. So where he covers from very basic, which is installing Python environment and covering the libraries which are required for data science like pandas, data frames, right? So he covers all those. So if you have basic knowledge of programming already, like loops, conditional statements, like if and else, if you have that knowledge, loops, if and else, if you have that knowledge, I think that is sufficient. uh, that is sufficient for you to get started with this course, because anyway while I teach any particular topic, we'll also try to implement them in programmatical way, because just learning theoretical is not enough, right, to get interview ready, because this course is mainly targeted for beginner to make you ready for an interview, data science interview. So we all will also see along the way, whenever we are discussing any topic, if required, will be implementing that in programmatical way also. Okay, so if you have those or basics of programming knowledge, you can directly get started. But if you are very beginner, then I would recommend you just watch these codes by Dave. I'll give the link in the description. Please follow that and start this code. Okay, anyway, so we'll start with first module. So what you will be learning in this module is that you'll be understanding about the basic, because this is like kind of a raw material for building any machine learning project or data science project. So this is about data. So I think I already covered this, what is data science. Sorry, one second. I have already covered this in one of my previous video. So so I have already covered this first topic, wherein I have discussed what is data science, machine learning, Gen AI, and also AI. So I have differentiated all these terms. Okay, so we'll start with this topic, which is types of data. So we'll be seeing what are different types of data available, like numerical, categorical, text, image, videos. Okay, all these are different types of data. We'll be seeing that. So the life cycle of machine learning project. So there is this cycle which is called crisp DM. So we'll see that as well. We'll see exploratory data analysis, wherein you'll try to see different plots, visualization techniques, way to use which plots and all. So like histograms, box plot, pair plots. So all these will be covering in this visualization or data EDA topic. And there are this identification outliers. These can be done using visualization as well as using some techniques using programming as well. So we'll see that as well. And trends, data pre-processing techniques like missing values, scaling, encoding, filling, and all, data imputation techniques and all, we'll be learning in data pre-processing. This is about understanding the data, which is first module. Moving on to second module, which is intuition behind ML. Okay, the intuition behind ML. So this module is very important, uh, and don't get scared by seeing these terms like probability concept, random variable distribution, and all. So these are mathematical concepts. Yes, there is mathematics involved for machine learning, because machine learning models are not magical, right? So we have to have some mathematical concepts. Don't worry, we will be not learning this as like a formulas, but it's very important for us to understand these concepts from probability to calculus, right? These topics are very important because most machine learning models are based on mathematical concepts only, correct? Example, Navy Base is one of the probability techniques. So Navy Base is one of the algorithms for classification. It uses probability concepts like conditional probability and all. So these are important topics, uh, which sets a foundations to understand further machine learning algorithms and math behind machine learning algorithms. Okay, so if you want me to give an example, I think you have seen, like, while any cricket match is going on, when you see see the score in any online site, there might be giving a chance of particular team winning, right? So how that chance of particular team is drawn from, right? Those people are applying machine learning models. One sec. So those people are applying machine learning models, and then so those people are giving probability. So this probability, or we can also say percentage, right? So they say that 65% chance is that team 1 will win, team 1, and 35 percentage chance, 35 percentage chance team 2, team 2. So they are saying this by applying a machine learning model onto certain data they have gathered. Like, when I say data, they have certain data like which team is playing, right? So which team is playing, uh, who are the bowlers and batsmen, what is the batsman order, how many overs left, right? and whether there are a lot of spinners or so these are kind of variables they'll be taking. So these are variables, so that is where these random variables will come. So whatever I have discussed, like these becomes variables, and these variables are passed to machine learning model, and that machine learning model will give a prediction saying that okay, at this point of time there is 65% chance that this team A will win. The same way that there is 35 remaining 35 chance percentage chance is that team 2 also might win, right? These are the these are the probabilities they are giving based on the variables they are passing, which is input variable. So that is where this random variable comes into picture. Okay, whatever the inputs are there, those are called random variables, and they'll be predicting the percentage of particular team winning. Okay, so that is where these random variables again, these distributions also, like Gaussian distribution, etc. These are very important again because a lot of real world uh, variables are Gaussian distributed. So we have to learn what is Gaussian distribution and all. So there is this descriptive statistics. We'll learn this descriptive statistics, like very basics, which is mean variance, percentiles, skewness, kurtosis, and all. Okay, and there is this sampling which is required, central limit theorem, which we will also focus on, confidence intervals, hypothesis testing. This is also one of the important topic. These p values, so vector and matrix multiplication, again this is from linear algebra. So dot product, projection, geometry, also data. We have eigenvalues, again this is one of the important topic. We'll not go too much depth on this eigenvalues and eigenvectors, but we will see this as a introduction part, because one algorithm or certain algorithms are using these eigenvalues and eigenvectors to optimize its optimization function. So I'll also teach you what is optimization and all. Okay, so this is about intuition behind machine learning. Okay, this is the third module, which is simplifying dimensions. Okay, to give an understanding of what these simplifying dimensions are, simply we can understand this by taking an example of that cricket use case. So we have seen like three variables or inputs, like how many overs left, who are the batsmen and who are the bowlers and all. These are certain variables, right? Well, like we already discussed like three or four variables. Let's say you have 100 variables, like let's say you are 100 variables, or 1000 variables for that matter, or 10,000 variables. Let's say you have 10,000 variables. You have to reduce them to make some meaningful information, because you can't pass those 1000 variables at a time, or you can't pass all the 10,000 variables to a model and let model decide which is important, right? You have to do some groundwork. So you will reduce those dimensions to, let's say, 100 or 50, to better understand what are the features which are important. Why this is not working? So you'll reduce them to 50 features. So those are done using something called as dimensionality reduction. Okay, so we will see what is dimensionality, why reduction is needed, dimensionality reduction is needed, feature scaling and normalization. There is this technique called PCA, which is dimensionality reduction technique. Okay, we will see the geometrical and mathematical intuition for that algorithm. We will also see visualization data in 2D and 3D. It's like we can plot the data in 2 dimensions and 3 dimensions also. So when we have variables, so we'll see that. We'll also see TSNE, which is again mostly used for visualization technique, right? It's a mostly visualization technique only. And we'll also see UMAP. We will also see interpreting latent space representations. That means we'll see how those 10,000 dimensions are represented using 50 dimensions, because if you convert any large scale to small scale, there will be some information loss. So we'll also see how those 10,000 dimensions are reduced to 50 dimensions, and we'll try to see them in using some way which is TSNE. Okay, so this is about third module. Moving on to fourth module, which is a supervised learning. So, so this is where it gets more interesting, because we'll be learning different machine learning techniques. These are classical machine learning techniques on which we'll be learning in this module. I'll also explain what is supervised learning later. But what we'll be learning in this module is regression versus classification. What is the difference? We'll be seeing the simplest algorithm, which is k-nearest neighbors. So we'll be seeing that in a mathematical as well as geometrical way. Okay, so we'll be also seeing the navy base, which is classification algorithm. We'll be seeing the probability based approach for that. We'll be seeing linear regression, which is again a classification based algorithm. We'll be seeing support vector machines. Again, this can be used for regression as well as classification. We'll be seeing techniques like margin maximization and kernels, because we also have kernel based SVMs for non-complex or for complex data. So decision trees, again, these are one of the mainstream algorithms when it comes to Kaggle, right? There is this Kaggle website where they have where they used to use these decision trees to win any competition at those times. So this is the very important algorithm. So we'll see what is entropy, information gain, gene impurity. All these are concepts under decision trees. Again, followed by these ensemble models. So these ensemble models are nothing but like when we have multiple models combined, these becomes ensembling models. Like each model is stacked onto each other, or each model cascaded, or we'll be using decision trees multiple times in single model. Then it becomes ensembling model. So we have certain things, a certain algorithm called random forest, bagging and boosting. So these are important models under ensembling modeling. So we'll also see uh, uh, how to tackle this bias and variance. Okay, so this is one of the important what we call uh, we can say drawback. So we have to reduce both bias and variance and get onto a middle ground. So that is where we'll be learning this bias and variance. And we also see model generalization. Okay, so that means models on real world use case, outage data, and cross validation and hyperparameter tuning. Okay, everything will be covering inside this fourth module. So this is more like a classical machine learning. So previously we used to not have neural networks. So in those days they used to use supervised classical machine learning techniques, right? Whatever we have the SORD, like support vector machines and all those are classical machine learning algorithms. Okay, here, so the term supervised learning means when we have both x and y. X means input, this is input, and this is output. So when we have y's also, to supervise the machine learning model, or to supervise the loss, that means the loss is dependent on y and also x, right? So there is this y is a person who is always supervising the loss and trying to reduce the loss, so that we achieve good accuracy or good performance. So that is what supervised means. When we have both x and y's, that becomes supervised machine learning. Okay, so moving on, there is this fifth module, which is evaluation metrics and model selection. Okay, so evaluation metrics are again classified into two types, like classification and regression. So these all accuracy, precision, recall, and defense score, confusion metrics, ROC, AUC, log loss, all these are classification metrics. Its aspect is a regression metric. Okay, so these evaluation metrics are very important, because till now you have just built a model, but how you will evaluate a model? Let's say you are for any use case you are selecting, you want to select any best model out of these all the algorithms. So when you have trained KNNAV based support vector machine algorithms on particular use case, you want to select which model is performing better, right? That you will do that you using evaluation metrics only. Like when you have good accuracy, the best accuracy, you will select that particular model. Again, that depends on use case, like which evaluation metrics to use. That is a problem dependent one, whether you'll be taking recall or whether you'll be considering accuracy or whether you'll be considering all the metrics combinedly. That depends on a use case. There is this handling imbalanced data sets, bias and variance data in evaluation, overfitting and underfitting. So these are very important concepts, again, overfitting and underfitting. So you will detect overfitting and underfitting, also will also fix them, and how to fix that overfitting and underfitting problem. So that is about fifth module. Moving on to sixth module, which is unsupervised machine learning. So we already saw what is supervised, right? When we have 5 values, it's called supervised. When we don't have output, just the input, then it is called unsupervised machine learning or unsupervised learning. So to give an example of this, let's say you want to let's say you are a government employee and you are a statistician, and government comes to you and gives a task to you, like that just group particular people from the city, so that this scheme will be allocated to those people only. Let's say you have 100 people, okay, and you want to group them. So you want to group them. So, but you don't know the previous groups. That means this is the group you're doing, or this is the grouping you're doing for the first time. Then you might not have any historical data, right? Then what you'll do is you'll go to the people and do a survey. You'll gather certain information like what is the age, what is the income, etc., etc., and based on that you'll have certain groups. You'll form certain groups, right? Let's say this is one group, these are another groups. So likewise you'll group them. So you'll say, okay, you'll go back to government. You'll say this is the category A or group A, cat A, and this is category B, okay, this is cat B. Likewise you'll give to the government, and government will further allocate the schemes to the targeted groups, correct? So that is where this clustering will come into picture. So how you'll group them is based on these techniques only. This k-means technique, hierarchical clustering, density based clustering. These are some of the grouping techniques, okay, you'll be applying on this data. You'll be also seeing dimensionality reduction as a clustering helper. So dimensionality reduction also helps in clustering clustering based techniques, okay, we'll see that as well. Yeah, we will also see evaluating clustering techniques, which is clustering metrics, silhouette score and inertia. These are some of the evaluation criteria or evaluation metrics for clustering. We'll also see the recommendation systems. So you might have seen the YouTube homepage, right? It has a lot of recommendations for us. So how those recommendations are working, we'll see that using collaborative filtering and content based filtering. These are two techniques under recommendation systems. So this is about this sixth module. Moving on to seventh module. So this becomes the introduction module for neural networks and deep learning. So till now we have saw the basics of basic and classical machine learning, like supervised machine learning models and unsupervised machine learning models. Now we will be seeing these neural networks, which comes under deep learning. So the concepts covered over here are the biology inspired foundation, that is how neural networks is interrelated with our brain neurons, or the neurons inside our mind or our brain. So we'll be seeing that. So we'll be seeing perceptrons and neurons. We'll be seeing activation functions. We'll be seeing multi-layer perceptrons, because when we stack multiple neurons, that becomes multi-layer perceptron. and we'll be seeing some techniques like back propagation, forward propagation and all. We'll be seeing gradient descent, which is very important because this is one of the technique which takes us to minimum loss, because we always try to go towards the minimum loss, which is 0. We'll see optimizers like SCD, ADAM, RMS prop. We'll see some regularization technique like dropout, L1, L2 regularization, batch normalization, etc. We'll also see some word to vec embeddings. Like there are some embeddings. We'll see that. Okay. So this is a basic foundation knowledge for deep learning. So without this module, you will not understand any latest trends in AI, which is Gen AI also. Everything is based on these basic topics, these foundational topics. So we have to cover these topics, and we have to really understand these topics before moving further to any other deep learning modules. So again, this when it comes to 8th module also, this is also deep learning module, but this is advanced bit because we'll be learning CV and NLP. CV stands for computer vision, and NLP stands for natural language processing. So computer vision is meant for vision task. That means whenever you have input as images or videos, that comes under computer vision, and when you have textual inputs or sequential inputs, that becomes uh, a text speech also. Everything becomes a natural language processing as an input. Okay, natural language processing takes an input as text or speech. Okay, so what we'll be dealing here is convolutional neural networks. Convolutional neural networks are the type of neural network where the input is image or multi-dimensional. So when the task becomes vision based, convolutional networks are the architectures or algorithms which we will be using. So we'll be seeing image processing and feature maps, which is part of CNNs only. So all these topics, pooling, padding, and convolution filters, all these are part of CNNs. And we'll also see some CNN classical architectures, so which they used to use previously, like LayNet, LXNet, VGG, ResNet. Okay, all these are some of the architectures they have created using CNNs. Okay, they offer some transfer learning techniques. Let's say you want to solve any problem of this computer vision, you'll apply these transfer learning weights and then build on top of that. So that's how classic CNN architectures were used. So we'll see what is transfer learning again. So this comes under whatever the techniques we'll be using, or whatever the architecture we'll be using. What we are doing is transfer we are using those weights. That means transfer learning. Okay, again we'll be seeing recurrent neural networks. This is whenever the input is text, this RNN comes into picture. We'll be seeing handling sequences. This is another architecture or algorithm, long short term memory plus terms. These are improved versions of LLM. Oh, sorry, these are input versions of RNNs. And again these GRUs are also improved versions of RNNs. So we'll be seeing the crux behind LLMs, transformers, and attention. So LLMs are using these transformers and attention mechanisms. Okay. Introduction to BERT, and we'll also see some Gen AI concepts. But anyway, further we'll be seeing the Gen AI concepts in 9th module. But we'll have some introduction over here, and we'll be seeing transfer learning and fine tuning. Okay. And coming to 9th module, so this is the buzz, right? If you are interested in LLMs and Gen AI in general, then this module is very interesting for you. Here you'll be learning introduction to generative AI, how language models work, tokens and embeddings, encoder versus decoder architectures. Okay, we'll be seeing that. What makes LLM powerful, because that is not a magic, right? We'll be seeing how they work. Sampling and text generation, so how LLMs are generating text. Prompt engineering, so how you can design a prompt. So there are different techniques, right, to give any prompt. Like there are few short, one shot and all. So we'll be seeing that. There is this COT technique and all. So we'll be seeing them. Fine tuning and model adoption. So we can't train the LLMs from scratch. So we have to tune them if you for any use case. So we'll be seeing that embeddings and vector databases for RAG. So when you are building any RAG, uh, again this RAG is one of the widely adopted use case right now, which is why every company is asking to build a RAG, because they have a lot of PDFs or textual based or image based uh, input files. So now they want to build a RAG on it. So that means they want to search, if they want to search anything from their databases having PDFs, they'll build a RAG, and whatever the query the RAG takes, it will give the answers according to the PDFs and the database, vector database they have created. That is how that is what RAG is about. So this is about Gen AI module. This is the last module, which is 10th module. So here you will be learning, or you will be solving two real world problems. One is from classical machine learning, and will be the other one is from Gen AI. So we'll solve those two use cases, and we'll also build an end-to-end system over here, because we also have to do deployment using Flask or Fast API. We'll also do that, and we'll also see what are the standards ways which we should follow when we are building end-to-end system, which is production ready, right? So we have to have some certain standards. We'll be seeing that as well. So everything will be covering in this module. Okay. I think that's about this roadmap. So I want you to follow everything in a sequential manner. Don't skip any videos. If you're really beginner, if you have some knowledge, you can skip some videos or some topics. But if you're really beginner, I would advise you to follow everything one by one, so that you become very confident to attend any interview. Okay. I think that's it for this video. If you have any doubts, or if anything addition is there, I'll add on to this course. And if you have any doubts also, you can comment down in the comment section.